measure standard deviation here. So a little over 1%, 1.22% a day. Okay. We all know if we annualize this, we multiply this by the square root of 252. The annualized daily standard deviation is 19.4. Okay. So let's do this again. We use weekly data. So you cover this. You can see from the numbers. They cover the same time period. You only get data, I think, on a Friday. Okay. So every Friday, so you only get one number every 5 numbers. So you combine the intermediate. Okay. So what do you expect the standard deviation to be on a weekly basis? Each week.
1.22 times square root of 5.
Right. So you expect to get a little bigger number. So the actual number is 2.43. Previously you got 1.22. If you double 1.22, that's 2.44. Right? That's square root of 4. But here it's square root of 5. It didn't double. So if you multiply this by the number of weeks in a year, that's 52. Okay. So the annual standard deviation annualized from weekly data. In our exam, we're still, this should give you the same number. You can see the annualized standard deviation from weekly data is 17.5. Okay? For the annualized standard deviation from daily data, it's 19.4. Okay? So remember, I gave you this example about 2 midterms, and then calculate the standard deviation for the combined grade. Okay? The standard deviation will be smaller if the correlation between 2 midterms is negative. Or the standard deviation will actually be bigger if the correlation is positive. So here, the standard deviation from annualized weekly number is smaller than the annualized standard deviation from daily number. So what does that mean? What does it imply? Does that imply a positive correlation over different days in a week, or negative correlation over different days? So it's really here, okay? It's really, when you annualize daily, we're assuming this row is 0. Within the 5 days in a week, we're assuming it's 0, okay? But that number is actually too high relative to the case of just using weekly number. Okay? So how do you make this very smaller? Do you need a positive row and negative row? You need a negative row. Okay? The stock return is actually slightly, not much, slightly negatively correlated. Okay? you need a slight negative correlation to create a smaller standard deviation from annualized weekly number. Okay. So guess stock in a day there's not much predictability. Okay. But when you have this is saying when you have many days that's going in one direction with negative correlation, it's going to give back some. Okay, not much. A very small amount. Okay. The correlation on the daily frequency. Let's try to measure this. How do you measure the correlation over time? So I'm going to copy all these numbers. Remember, this number is daily. Okay? And then these are daily returns we created. Okay? I'm going to copy this, but I'm going to shift this down by one row. So here, I'm going to copy this number here. Okay? And I'm going to copy the next number one day as well. So this number is pointing to the day before. Okay? So this is the return. This is the return with a lag. Okay? When I say a lag return, it's like this is a lag one return. It's a return from a day ago. Okay? One day earlier. So let's calculate the correlation. Let's calculate the correlation between these two. Correlation return and return with the lag. Okay, this is lag one lag. So anybody still remember formula function for correlation? Have you ever done this? Excel has a built-in correlation formula. Correl, C-O-R-R-E-L. Okay, and then all you need is highlight these two columns of data. These numbers and these numbers. These column D is actually the same as column C, but it go down by one row. Otherwise they're the same. This is what you get, okay? 0.067 negative. Okay? This is slightly negative, but it's very, very small. Okay? So this correlation implies something like this. Okay? This tiny. If SPY goes up at $1, okay, in a day, the correlation is negative, about negative 7%. It says the next day, after a big day, it goes up by $1. The next day, it's going to go give back. It's going to move in the opposite direction for about 7 pennies. Okay? You can predict. You can sort of after a big up day, next day, probably go down a little bit. Okay? Or after a very big down day, next day it's going to go up a little bit. But it's not very. The magnitude is very small. It's hard to see. Let's see whether we can graph this. Let's see whether the picture will be better. Okay. So let's put them into a scatter plot. Do you really see a strong pattern here? So this axis is a return today, and this axis is a return with one leg. Okay? You don't really see much. Okay? It seems like all over the place. But here also there are probably a little bit extra points. Some extra points scatter plot. I'm not sure which one is which. And the horizontal should be the first row. Yeah. This is the return. This is the likelihood. Okay. But if they have negative correlation, it means if you wanna fit a line, this should go through the second and fourth quadrant. You should have something like that. I can't see it, but it's very, very small. Okay. So down the road, we're gonna explain regressions. There's a very small step between correlation, covariance, and the simple linear regression. Okay. In the regression world, we talk about something called R square. Okay. That's how much variation you can explain. The percentage, the fraction of variance you can explain with your regression. Okay. The R square term. Okay. The R square term turns out to be correlation square. Okay. The correlation here is less than 0.1. We're going to talk about that at that point. I'm just going to give you a preview. The correlation we have here is minus 0.07. It's less than 0.1. So if you square that term, it's going to be less than 0.01. So in other words, your R square in this regression is less than 1%. Okay? If you talk about 1% R square, the labor economists, health economists, who run regressions with their data, they laugh at you. 1% regression, 1% R squared, there's nothing. You can't explain anything. Okay? In finance, if you get 1%, you're very lucky. Okay? This is consistent with Professor Fama's hypothesis. Market is pretty efficient. Okay? If you look at how much variation there is, you can explain. With historical data, look at what happened yesterday, the day before yesterday. You can predict, less than 1% of the future. Okay, that's just how much you have. Okay, that's the world we operate in. Okay, there's not a whole lot of time series correlation. You can't predict much. Okay, there's small negative correlation. It's not very high. But if you have fast computer, you discipline, actually 7 penny, the days where you have 7 pennies in movement, that's big enough. You can get in and get out of SPY, $170 stock. You can do a round trip at the cost of 1 penny. Okay? But the problem here is you only have a 7 penny edge out of something that can move $1. It's very, very small. It's a very, very small edge. Okay? So what happens is when people every day, on average, you make 7 pennies. But sometimes you lose $1, sometimes you make $1. The problem is when people lose $1, they don't take the loss. They keep on holding on to it, and then that $1 becomes $2, $2 becomes $4.